of gas. Volume of gas measured in different conditions. The first is the condition of RTP. RTP, room temperature pressure, 25 degrees Celsius, and pressure of 1 atm. In this condition, every mole of gas occupies 24 dm³ of volume. The second condition is STP, standard temperature pressure. In this, volume of gas measured at temperature of 0 degrees Celsius and pressure of 1 atm. In this condition, 1 mole of gas occupies 22.4 dm³. When we have no data of pressure or temperature, we can make comparison, such as when 1 mole of O2 occupies, let's say, 25 dm³, then there is question, what is the volume of half mole of other gas, let's say CO2. Then we can compare to this. So if 1 mole is 25, then for half mole of CO2, even though the substance not the same, but the condition will be the same. So for half mole, the volume is half times 25 dm³. Then we have 12.5 dm³ of CO2. Or another condition, when we know the pressure and temperature, but not at this temperature, not RTP, not STP, then we calculate the volume of gas using ideal gas law, PV equals nRT. nRT is the constant, T is the temperature, and V is the volume, P is the pressure. So once again, about AR and MR. Relative atomic mass. AR is the weighted average mass of naturally occurring atoms of an element on a scale where an atom of carbon-12 has a mass of exactly 12 units. AR of element Y is the average mass of one atom of element Y times 12. This times 12 comes from 1/12 times mass of 1 mole of carbon-12. For MR, relative molecular mass, this one is the relative mass of one molecule, a compound on scale where an atom of carbon-12 has mass of exactly 12 units. The same, but MR is for compound. For example, for compound Z, then MR is relative mass of one molecule of compound Z times 12 over mass of one atom of carbon-12. Now we come to an example how we calculate the relative formula mass. This formula mass, not molecular mass, is for ionic compound. As we know, for ionic compound, the particle is not molecule, but unit. The CaCO3 is the empirical formula. But the way we calculate the MR, the same as we calculate the MR of covalent compound. For ionic compound CaCO3, one unit composed of 1 calcium, 1 carbon, and 3 oxygen atoms. So the MR will be 1 AR of Ca plus 1 AR of carbon plus 3 times AR of oxygen. This AR we get from the data: 40 for calcium, for carbon 12, for oxygen 16. But there are 3 oxygen atoms, so the AR times 3. So we get 40 plus 12 plus 3 times 16, 48. So the MR is 100. Here we have a question: 0.5 mole, half mole of lead nitrate is mixed with 0.1 mole of chromium sulfate in water. The maximum number of moles of lead sulfate that can be obtained is, so there is a reaction here. We have lead nitrate, lead is Pb, 2 plus, nitrate is NO3 minus, so the formula of lead nitrate is Pb in brackets NO3 times 2, because the charge of NO3 only -1, but the charge of Pb is +2. So to be neutral, the nitrate should be 2. Then mix with chromium sulfate, Cr3 plus, and SO4 for sulfate, 2 minus. Then the formula become Cr2SO4 times 3. So we switch the charge to be neutral. Then this will react to produce the decomposition here, become PbSO4, because Pb 2 plus and SO4 2 minus, so the formula just PbSO4 plus CrNO3 times 3. Why times 3? Because NO3 is -1 and Cr is +3. So we get CrNO3 times 3. Then after that we balance the equation. We have 2 Cr here, so this one is times 2, and for nitrate, here we have 2 times 3, 6 nitrate or NO3. Here we have only 2. So this part should be multiplied by 3. Then after that we get 3 Pb. Here only 1. So you multiply this by 3. So we get this, and check it once again. Number of oxygen is 6 times 3, 18, plus oxygen here 12. So the number of oxygen is 30 on the left hand side of the equation. And then on the right hand side you have 12 plus 9 times 2. 18. So the number of oxygen is 30. If the number of oxygen the same, then we confident that this equation already balanced. So I write once again, the equation is 3 PbNO3 times 2 plus Cr2SO4 times 3 to be 3 PbSO4 plus 2CrNO3 times 3. Then we have the data. Half mole of lead nitrate, this one is 0.5 mole. Then the question is the maximum number of moles of lead sulfate, this one. You compare. What is asked is the number of mole of PbSO4. Then we notice the coefficient is 3 and the data Pb nitrate, the coefficient is 3 as well. So the number of mole will be the same because the ratio of coefficient actually is the ratio of mole of the substances. So we get 0.5 mole. So the answer is B.